Zscaler Zero Trust device segmentation does east-west microsegmentation to prevent lateral movement. In this video, I'll cover what's AirGap classes, the use cases it caters, and then we'll dive into the configuration and you'll see AirGap Plus in action. So let's get started. As you already know, Zscaler device segmentation minimizes the attack surface and east-west lateral movement by ring-fencing each device in a network of one by assigning a subnet mask of /32. Not all systems or network support /32 subnet mask. Some of these systems, though, cannot be fenced in a network of one, but may still require AirGap protection. AirGap Plus is a solution for such use cases as it implements Micro-Subnet supporting subnet mask between /27 and /30. The inter-micro-subnet traffic is routed through the Zero Trust device segmentation gateway for inspection and policy enforcement, whereas communication within the micro-subnet does not have the gateway in the data path. Let's take a deeper look at how AirGap Plus works. So here's the topology for today's demo. We have two Zero Trust device segmentation gateways running in a cluster. On the LAN side of the cluster, we have our four endpoints, Linux A, B, C, and D, whereas on the WAN side is the DHCP server. So DHCP service running in a DHCP server mode is a requirement for AirGap Plus configuration. Initially, we have all the four endpoints air-gapped in a network of one. As you'll see that we have /32 IP assigned for all four of them. We'll then create a micro-subnet and we'll move Linux A and B into the /30 micro-subnet, leaving Linux C and D behind as they were before in a ring-fenced network of one. So the three configuration steps required is that number one, we'll enable the AirGap Plus at the VLAN level, defining that it's a /30 micro-subnet with the AirGap range. Then we'll have an endpoint in a CSV imported in the AirGap configuration. And then finally, we'll have the IP address change from DHCP to static for the two endpoints that will move in the micro-subnet of /30. So once the AirGap Plus is enabled, we'll see that the two endpoints that we have moved into micro-subnet of /30, previously they had /32 IP assigned, but then we'll release and renew the DHCP leaves and you'll see that they have /30 IP assigned now. Whereas for the other two endpoints, Linux C and D, even though you renew the lease, they continue to have the /32 IP because they were not made a member of that micro-subnet. We'll then create the two segmentation policies to control the communication. The first policy is that the communication from all the non-AirGap Plus, which is C and D, should not be sourced for a destination of A and B, and the action is set to reject. Whereas the second policy is doing the same thing in the reverse direction, that any communication sourced from the AirGap Plus endpoints, which is A and B, for destination C and D should also be rejected. So this will limit the communication within the micro-subnet, and the ring fence will also talk to each other, but there is no communication between the /30 and /32. So here is the AirGap management portal. This is my site, and the DHCP service, as you could see, is set to DHCP server. At the VLAN level, we have AirGap Plus enabled. This is the subnet mask for the micro-subnet and the micro-subnet range here. These are my assets in port 50. You could see that for Linux A and B, which are member of micro-subnet, the IP address assignment is static, whereas for the other two endpoints, they are air-gapped and the IP is assigned by the DHCP AirGap server. They are still ring-fenced in a network of one. Here are the AirGap Plus policies, which block any communication from A and B to C and D, whereas also in the reverse direction. All the VMs that I have in this are running in ESXi. As you could see that I have the IP for A and B at the top have /32 mask, so they are in micro-subnet, whereas the bottom two C and D are in /32, so they are still ring fenced with a mask of /32, network of 1. So A and B should talk to each other, whereas they should not talk to C and D, and similarly C and D, which are outside the micro-subnet, should also talk to each other but not to A and B. So let's just quickly verify. From A, if I try to reach out to B, you could see that as expected it is working, whereas for the ring fence network, which is outside the micro-subnet, this is not working. Similarly, from B also, if I reach out to A, this works, whereas if I try to reach out to either C or D, that doesn't work. Let's quickly verify in the reverse direction that if C tried to reach to A, which is in the micro-subnet, this is not allowed, whereas C should be able to talk to D. So this is exactly what we wanted, that the two machines that are in the micro-subnet should talk to each other, whereas not outside, and the same is true for the ring-fenced VM C and D, that they should talk to each other, but not to the two VMs that are part of the micro-subnet. So hope you find the information presented in this helpful. If you have any questions, feel free to reach out, and also check Zscaler's website for more details on zero trust device segmentation. Thanks and have a great day.